Okay, so today we're going to do the small wind tunnel practical as part of chapter 5 on similarity and non-dimensional analysis. So we're going to go through a process where we look at small models, we derive some values from the experiment, and then from that we are able to translate them into non-dimensional values, and we can use them to compare these different cases to each other as well as compare them to bigger cases. So this is the wind tunnel that we are using, and I'm just going to go through a couple of parts of it. At the back here we have what is known as the honeycomb, and so air is sucked in through the wind tunnel from this side, and the honeycomb helps to straighten out the flow, so whatever it is on the outside of this gets straightened out. It goes through the wind tunnel. We have our testing section, so in here you'll see now we have the airfoil with the pressure taps on the airfoil, and the teaching assistant will be adjusting this for you, but that's where we have our test section. And then as we move beyond to the other side, we have the fan on the other side, so it's sucking the air through from the left side of this wind tunnel over the testing model all the way to the right. So in this case we're actually testing for pressure, so the values we get run through these pressure taps, and they attach to a manometer, which you would have learnt about in chapter 2, and through this we actually get volt readings, and from that we get pressure, and so we can use the pressure results that we get to translate that into pressure coefficient, which is a non-dimensional value. So the process here is getting the information in volts, then making sure they are translated to pressure, and then dynamic and static pressure is used to calculate the pressure coefficient, from which you can compare these different angles. If you look closely, there's an angle of attack meter here at the top, so that is something that the teaching assistant will change, and it's currently standing at 0, and so every time you change an angle you're changing it around that meter. Okay, so the first practical we're doing is airflow over a 2D streamlined body, and we open the software at exercise F to launch the program. Once the program is open, we can go to the ambient temperature, changing it to what is the current temperature in the lab. We zero the static pressure. We move to setup to select automatic and continuous. Press OK twice. Now we are ready to switch the fan on. Before we do that, we enter into the fan speed approximately 40 to start with, and we click on the fan on button. You will hear the fan coming on, and at 40 fan speed the velocity will be approximately 7.1 meters per second. Now you would have calculated the velocity that you require based on the Reynolds number given, and so once you see what the velocity is, you can gradually increase the fan speed to get up to the velocity that you require for this practical specifically. You will enter into attached notes the angle of attack. So here you can enter angle of attack 0, which is set at the moment, just to keep track of what angle we are testing. You can switch to table mode and press go. We're going to take 10 readings, and after about 10 readings we'll press stop and return to the diagram mode. Back in diagram, we switch off the fan by unclicking the fan on button. We wait for it to completely get down to 0, and the teaching assistant will adjust the airfoil to a different angle, and we restart the process again. For the second part of the practical, we're doing some force measurements. So this is the force balance that we have attached to, you'll see the small sphere on the inside of the wind tunnel, and at the back of the sphere we have the wake rake. So the wake rake is again attached to the manometer that's taking the pressure readings. So we'll have two sets of readings this time, one for the forces experienced by the sphere and pressure readings for what is happening in the wake of the sphere. So in the same way as we did before, we will take this information, change it into non-dimensional values, and then we're able to, once the values are in non-dimensional form, compare them to each other. So we're going to test different shapes. So we'll test 2 spheres and 1 golf ball, and then that's what you will be comparing in your final report. For the second part of the practical, we're looking at the flow over bluff bodies. So we select exercise E as we open the software. Once we open the software up, we can change the ambient temperature to what it is on the day, 0 the drag, 0 the static pressure, and we are going to select yes to the wake rate because we are using that for this part of the practical. We again go to the setup, change to automatic and continuous, and the last thing is to make sure that the shape used is, in this case, the small smooth sphere. Okay, so once you've selected everything, we can now go to the fan speed. We change the fan speed to 20 to start with. We're going to test 3 different fan speeds, and the teaching assistant will give you the 3 fan speeds that you are testing at. And once we have the fan speed entered, we click fan on. We wait for the fan to come on, and we look at the velocity. The velocity will be a specific value, so at 20 it's approximately 3.4 meters per second. We just wait for that to stabilize a little bit. We go to table view, we press go. We're going to take 10 recordings at this first velocity. So waiting for 10 recordings, this will give you 10 readings to do an averaging from. After 10 recordings, we push stop, back to diagram view, and we can take the fan speed up. So let's take it up to about 40. And now you'll see that the velocity is changing to approximately 6.3 or 6.4. Just give it a moment to make sure it's not fluctuating too much. And then once you are ready, we go back to table view, press go for 10 recordings. You will see that the 10 recordings are now recorded at a different fan speed. Also make sure to check that the drag force is also changing, otherwise it might not be reading properly from the force balance. After your 10 readings, we press stop, go back to table view, to diagram view, and then we take the fan speed up to 50. The final fan speed, we go through the same process. Once we are ready, go to table view, press go, 10 readings. After 10 readings, we press stop, and we return to diagram view. After you've done all the experiments with the one small sphere, we're going to switch the fan off. And at this stage, the teaching assistant will change to the new shape. And after you've conducted all 3 shapes, we're going to go through a process of saving. Okay, to save the work, you go to the Save As button, select the folder that the TA has assigned for this practical, enter your group number as the file name, so group number. Make sure that the file type is set to Excel 4, and then save.